Hello learners, I am Dr. Nidhi Mathur and the subject expert of this episode is Dr. Neeti Mathur, teaching in National Law University, Jodhpur, Rajasthan. Previously, we discussed linear programming in operations research. Our topic of discussion for today is the transportation theory. We all have ordered products online from Amazon. When we talk about Amazon, the question comes to our mind is about their quick logistics. The company is operating across globe and deals with numerous vendors and customers. Then how do they deliver the right product to the right customer, and that too in less span of days? Well, all such companies and transport companies with logistics based business perform tasks on the basis of transportation theory of linear programming. You must be wondering what exactly is transportation theory. Let me explain this to you. Transportation problem is a linear programming problem that considers the goods to be transported from a source of origin to destination depending upon the supply and demand of the sources and destination. The primary purpose of transportation theory is to minimize the total cost of transportation. This theory is also called as Hitchcock problem. Types of transportation problems. Transportation problems are divided into two categories: balanced and unbalanced category. Balanced transportation problem. The problem is called a balanced transportation problem when both supplies and demands are equal. Unbalanced transportation problem. The problem is said to be unbalanced transportation problem when the supply and demand are not equal. Therefore, to resolve this problem, either a dummy row or a dummy column is added as per the requirement to convert it into a balanced problem. It is then solved as a balanced problem. Let us discuss the method to solve these transportation problems. These methods are northwest corner cell method, least call cell method, Vogel's approximation method. As you can see in the table, this is the structure of transportation problem. D1 to D4 is the destination, O1 to O4 is the origin or source of goods, S1 to S4 depicts supply of goods, D1 to D4 in small letters depicts demand of goods, and C11 to 44 depicts costs of transportation. Let us discuss the key terminologies used in transportation problem. Here, supply constraint indicates the limitation of supply of goods to the market, and demand constraint indicates the limitations of meeting the market demand of the goods. Non-negative restriction indicates that the numeric value should not be lesser than 0. Feasible solution of the transportation problem is a set of non-negative values that satisfy demand and supply constraints. Basic feasible solution is feasible solution if it contains not more than one m plus n minus 1 allocation, where m is the number of rows and n is the number of columns. The optimal solution may be a feasible or basic feasible solution that minimizes transportation cost. Non-degenerate basic feasible solution is a basic feasible solution. The total number of non-negative allocation is exactly m rows plus n columns minus 1, and these m plus n minus 1 allocations are in independent positions. Degenerate basic feasible solution is a basic feasible solution in which the total number of non-negative allocation is less than m plus n minus 1. Now, let us discuss the northwest corner rule in detail. The northwest corner rule calculates the initial feasible solution of the transportation problem. The name northwest corner is assigned to this method as the basic variables are selected from the extreme left corner. We can understand this method by solving a problem. As you can see in the table, there are 3 factories and 4 warehouses. The demand and supply for transporting an item from each factory to each warehouse has been mentioned. We have to find a feasible solution for this transportation problem. To solve this problem, in the first step, we will find out if it is a balanced problem or not. We will calculate the total demand and supply, as here the total demand is equal to total supply, which is 100. Therefore, the given problem is a balanced transportation problem. In the second step, after checking if the problem is a balanced problem or an unbalanced problem, we will apply the northwest corner rule to the table or the matrix. In the given matrix, the cell corresponding to factory 1, warehouse 1 or F1 W1 is the northwest corner. We will now compare the demand and supply corresponding to this cell. After comparing, we found out that the demand is 20 units and the supply is 30 units. We will take the lower value, that is 20 units, and assign it to the cell corresponding to F1 W1. As a result of this, the supply will be 10 units, that is 30 minus 20, and demand will be 0. When the demand will be 0, we will cancel out the entire demand column. In the third step, we will again apply the northwest corner rule. Since W1 column is already cancelled because of 0 value in the demand column, the new northwest corner is the cell corresponding to F1 W2. Again, we will compare demand and supply. Demand is 40 units and supply is 10 units. Since supply value is lower as compared to demand value, we will assign supply value, that is 10, to the northwest corner. Now, supply is 0 because we have allocated 10 units of supply to F1 W2 cell. This row will be cancelled now, as supply value has become 0 for this value. On the other hand, demand value has gone down to 30, that is 40 minus 10. In the fourth step, again we will look for the northwest corner method. Now the northwest corner is the cell corresponding to F2 W2. We will again compare demand and supply. Since demand value is low, we will assign 30 units to this cell. The demand column will be cancelled as demand is now 0. Supply will be 50 minus 30, that is 20 units. In the fifth step, again we will look for the northwest corner method. Now, the northwest corner is the cell corresponding to F2 W3. We will again compare demand and supply. Since supply value is low, we will assign 20 units to this cell. The supply row will be cancelled as supply is now 0. Demand will be 30 minus 20, that is 10 units. In the sixth step, we will again find the northwest corner. The cell corresponding to F3 W3 is the northwest corner now. After comparing demand and supply value, we will assign 10 units of demand to this cell and cancel the demand column. The supply will be 20 minus 10 units, that is 10 units. In the seventh step, we will again find the northwest corner. The cell corresponding to F3 W4 is the northwest corner now. After comparing demand and supply value, we will assign 10 units of demand to this cell and cancel the demand column. The demand and supply are equal here. So, both demand and supply corresponding to this cell will be 0. In the last step, we will multiply value with the cell value in each cell and add them together to derive basic feasible solution. That is 2 multiplied by 20 plus 3 multiplied by 10 plus 4 multiplied by 30 plus 3 multiplied by 20 plus 6 multiplied by 10 plus 10 multiplied by 10, which is equal to rupees 410. The next method for solving transportation problem is the least cost method. This method is used to obtain the initial feasible solution for the transportation problem. The allocation is done with the cell which has the minimum cost. The lower cost cells are selected over the higher cost cell, so that the least cost of transportation can be obtained. This method gives more optimal results than the northwest corner, as it considers the shipping cost while making the allocation. On the other hand, the northwest corner method only considers the availability and supply requirement, and allocation begin with the extreme left corner irrespective of the shipping cost. We are using the same matrix to solve the transportation problem using least cost method. There are 3 factories and 4 warehouses. The demand and supply for transporting an item from each factory to each warehouse has been mentioned. We have to find a feasible solution for this transportation problem. In the first step, we will check if it is balanced problem or not. Since the demand and supply is same, that is 100, it is a balanced problem. In the second step, we will identify the cells with minimum cost from the entire matrix. Here you will see that the cell corresponding with F1W1, F1W3 and F2W4 have the least value, that is 2. So, we will compare the demand and supply and assign whichever is low to the respective cell. In F1W1, demand is low as compared to supply. Therefore, we will assign 20 here and cancel the entire demand column, since the value of demand is now 0. On the other hand, the supply value corresponding to this cell will become 30 minus 20, that is 10. Now, we will look at cell corresponding to F1W3. Here, supply is less, so we will assign 10 units and cancel the supply row. The demand will become 30 minus 10, that is 20. We are now looking at cell corresponding to F2W4. The demand is less, so we will assign 10 to this cell and cancel the demand column as the demand value is 0 now. The supply row value will be 50 minus 10, that is 40. In the next step, we will consider the next least value, that is bigger than 2. So, the value is 3, which is in the cells corresponding to F2W3 and F3W2. In cell corresponding to F2W2, we will assign 20 after comparing demand and supply, which is lesser. The demand value will become 0 and the column will be cancelled. The supply row value will be 40 minus 20, that is 20. Now, in cell corresponding to F3W2, we will assign 20 after comparing demand and supply, which is lesser. The supply row value will be 0 and demand will be 40 minus 20, that is 20. For the next step, we are left with the only cell, that is F2W2. Since demand and supply value is equal, we will assign 20 to the cell and both demand and supply row and column will be 0. In the last step, we will multiply value with the cell value in each cell and add them together to derive basic feasible solution. That is 2 multiplied by 20 plus 2 multiplied by 10 plus 4 multiplied by 20 plus 3 multiplied by 20 plus 2 multiplied by 10 plus 3 multiplied by 20, which is equal to rupees 280. This rupees 280 is the least cost for transporting an item from factory to warehouse. This value is lesser as compared to the northwest corner method. The next method for resolving a transportation problem is the Vogel's approximation method, or VAM. It is an iterative procedure to calculate the initial feasible solution of the transportation problem. Like least cost method, this method also considers the shipping cost, but in a relative sense. It provides better results in comparison to other methods for finding initial basic feasible solution for a transportation problem. We are using this matrix to solve the transportation problem using Vogel's approximation method. There are 3 factories and 4 warehouses. The demand and supply for transporting an item from each factory to each warehouse has been mentioned. We have to find a feasible solution for this transportation problem. The first step to solve a balanced transportation problem is to find the row difference and column difference of each row and each column. Here, we will find the row difference by finding the difference between the least and next least value. For example, in row 1, least value is 1 and next least value is 2. So, the difference is 1. In the second row, least value is 2 and next least value is 5. So, the difference is 3. And in the third row, least value is 3 and next least value is 5. So, the difference is 2. Similarly, for the column difference, the difference between the least and next least value will be considered. For example, in column 1, least value is 1 and next least value is 2. So, the difference is 1. In the second column, least value is 2 and next least value is 5. So, the difference is 3. In the third column, least value is 4 and next least value is 7. So, the difference is 3. And in the fourth column, least value is 6 and next least value is 8. So, the difference is 2. In the second step, we will take the maximum penalty or the maximum number from the row difference. It is the value 3. This value appears in row 2. So, we will now find the least value in row 2. F2W1 cell has the least value, that is 2. Now, compare the demand and supply and assign the demand 20. The supply is now 50 minus 20, that is 30. Since the demand is 0, the entire column will be cancelled as we have allocated the demand to the cell. The maximum penalty, that is value 3, is also appearing in column 2 and 3. So, we will assign supply or demand, whichever is lesser, to the least value in column 2. We have assigned it to the least value 2 in F1W2 cell. So, the supply is 0. As we have allocated supply 30 units to the cell, the entire row will be cancelled and demand is now 40 minus 30, that is 10. Now, in the third column, the least value is 7, which is appearing in row 2 and 3. So, you can allocate it to any row. Here we have chosen row 2. The cell F2W3 has least value 7. So, we will assign 30 to it. Here you will notice that the demand and supply are equal. So, we can cancel both column and row corresponding to the cell. Now, we are left with 2 columns and 1 row. We will again find the row and column difference. Since 2 rows are already cancelled, the difference will be nil. And for the last row, the difference between least value and next least value, that is 2. So, we will find the least value in the row, that is 5, and we will allocate demand 10 units to it. The demand column will be cancelled as the demand value is now 0. The supply column is now 20 minus 10, that is 10. Now, the only value remaining in the matrix is in cell F3W4. Since the demand and supply are now equal, we will assign 10 units to this cell. In the last step, we will multiply value with the cell value in each cell and add them together to derive basic feasible solution as per the Vogel's approximation method, that is 2 multiplied by 30 plus 2 multiplied by 20 plus 7 multiplied by 30 plus 5 multiplied by 10 plus 8 multiplied by 10, which is equal to rupees 440. This rupees 440 is the cost for transporting an item from factory to warehouse as per the Vogel's approximation method. So that is all for today. Hope you have understood. We will meet in the next episode with a new topic. Till then, take care and goodbye.